This lesson has been brought to you by Limitless Learning TT. For additional videos as well as the services we offer, please visit www.limitlesslearningtt.com. We are currently located in Chaguanas and also facilitate sessions online. If you struggle with math or know someone who does and would benefit from one-on-one tutoring, please send us an email at limitlesslearningtt@gmail.com, or you can give us a call at 868-354-3115 for the cost and available times. In this video, we will provide the solutions for number 5 and number 6 of the June 2015 Cape Pure Math Unit 1, Paper 2. Number 5, part A says let f be a function defined as f of x is a sine of ax over x if x is not equal to 0 and a is not equal to 0, or f of x is equal to 4 if x is equal to 0. And they say if f is continuous at x is equal to 0, then determine the value of a. So if f of x is continuous at x is equal to 0, then that means that the limit as x goes to 0 of sine ax over x must be equal to 4. So I've rewritten that step. The limit as x goes to 0 of sine ax over x must be equal to 4. So my second step, what I would have done is introduced an a on the denominator, which is right here, and whatever you do to one side you must do to the other side. So I divided both sides by a. So I divided sine ax by a, and I also introduced that same a in the denominator on the right hand side. The reason why I did that is because the limit as x tends to 0 of sine x over x is always equal to 1. So because I had sine of ax in my numerator, I know I needed to introduce an ax into my denominator so that as I take the limit, that value is going to go to 1. And now I end up with 1 on my left-hand side is equal to 4 divided by a, and make a the subject, so therefore a is equal to 4, which our question was asking us to find. Part B, using first principles, we're going to determine the derivative of f of x, which is equal to sine of 2x. So when we're finding the derivative according to our first principles method, it means that the derivative of f of x, which is f prime of x, is going to be equal to the limit as h goes to 0 of f of x plus h minus f of x over h. Now we know that the f of x that we are given is sine of 2x. So therefore, using our first principle methods and using the fact that f of x is equal to sine of 2x, we get that f prime of x is equal to the limit as h tends to 0 of sine of 2 times x plus h minus sine of 2x all over h. Right? So f of x plus h becomes sine of 2 times x plus h. F of x, of course, is our sine 2x, and then all of that is divided by h. So now what we're going to do is expand our brackets. So we're going to multiply out this sine of 2 times x plus h. Right, so that's 2 times x and 2 times h to get sine of 2x plus 2h. So now we have f dash of x is equal to the limit as h tends to 0 of sine of 2x plus 2h minus sine of 2x all divided by h. At this point in time, we're going to remember our sum formula for sine, which is sine of a plus b is equal to sine a times cos of b plus cos of a sine of b. So that gives us sine of 2x cos of 2h plus cos of 2h sine of 2h minus sine 2x all over h. So my first term, which is this term, and my last term both have sine of 2x in common. So I'm going to put these two terms together, and then I'm going to list this term after. So I'm just rearranging our numerator to get sine of 2x cos 2h minus sine of 2x plus cos 2x sine 2h, all divided by h. And since both my first and my second term have sine 2x in common, I'm going to pull out the sine 2x, and that's going to leave me with sine of 2x into cos 2h minus 1 plus my last term, which is cos 2x sine 2h, all over h. At this point in my limit, I have trigonometric functions on my numerator, and I have an h in my denominator. Now, when dealing with limits and trigonometric functions, there are two specifically that you want to remember. Those two functions are the limit as h tends to 0 of sine x over x is equal to 1. And my second function that I want to remember is the limit as h tends to 0 of cos x minus 1 over x is equal to 0. Now, when I look at the question that I have, when it comes to cos, I have a cos 2h minus 1 on my numerator. If I want to use this function here, I must have a 2h in my denominator. Because remember, cos of x minus 1 over x, so cos of 2h minus 1 should be divided by 2h. The same thing, if I look at my sine 2h, and I want it to look like this function here, that means that I should have a 2 on my denominator. Now we know when we're dealing with limits that we can only introduce 1. The number 1. We can't just multiply by 2 or divide by 2, but we can always multiply by 1, because 1 by anything is the number, and the number divided by 1 is the number. So 1 is the lucky thing. So what we're going to do here is we're going to do a little trick when we multiply this limit by the number 1. So now I have 1 times sine of 2x times cos of 2h minus 1 plus cos of 2x sine of 2h over h. But we know that we can rewrite 1 as a number of things. I am going to choose 1 to be represented as 2 over 2. 2 divided by 2 is 1, so now I'm going to replace 1 with 2 divided by 2. So this is now my result. I've replaced the number 1 with 2 divided by 2, which is also 1. Because of this, I can now place this 2 next to my h to get 2h on my denominator, so that I will be able to utilize these two functions on the bottom here. Right, so now you can see that I have 2h on my denominator. My 2 is still here on the outside, it hasn't disappeared, and I'm dealing with the same function that I had in the previous step. So now, because I have cos of 2h minus h over 2h, and I also have sine of 2h divided by 2h, I can now use these two functions that I have at the bottom here, this one and this one. This means the limit as h goes to 0 of cos 2h minus 1 over 2h is going to go to 0. So this is going to give me 0. And then sine of 2h divided by 2h is going to give me 1 as the limit goes from h to 0. So now I have 2 times sine of 2x multiplied by 0, because limit of h tends to 0 of cos 2h minus 1 over h over 2h is 0, as we found out from before. And then I now have cos of 2x times 1 because my limit as h tends to 0 of sine 2h over 2h is 1. Right? Anything times 0 is going to be 0. So this term here is going to go to 0. And 1 times anything is itself. So I'm now left with f prime of x is equal to 2 times cos of 2x, which is my final answer. Part C. If y is equal to 2x divided by the square root of 1 plus x squared, show that x times dy dx is equal to y divided by 1 plus x squared. Okay, so we've been given y is equal to 2x all over the square root of 1 plus x squared. Another way of rewriting that is 2x divided by 1 plus x squared all to the power of 1/2. So now we're going to differentiate with respect to x, keeping in mind that at the end of this we want to show that x times dy dx is equal to y divided by 1 plus x squared. So because we have a fraction, we are going to utilize the quotient rule when we're differentiating with respect to x. Therefore, this means that 2x is going to be our u, and 1 plus x squared all to the power of 1/2 is going to be our v. And when we're using the quotient rule, it says that v du dx, well, I should say that the differential of a fraction of the form u over v is going to be v du dx minus u dv dx all over v squared. So our v is going to be 1 plus x squared to the power of 1/2 times du dx, which is the differential of 2x, which is 2, minus u, our u is 2x, times the differential of our denominator, which is this power of 1/2 comes down to be a coefficient. We replace 1 plus x squared, and then we change the power to 1/2 minus 1, which becomes negative 1/2, and then we multiply by the differential inside our bracket. So the differential of 1 is 0, and the differential of x squared is going to be 2x. Alright, so we've now done v du dx minus u dv dx, and then all of that is divided by our denominator, which is 1 plus x squared to the power of 1/2 squared. So now we're going to simplify and neaten up. I've taken this 2 and I've just brought it to the front, so this becomes 2 times 1 plus x squared to the power of 1/2. And now we're looking at what's in between here, and we can multiply 1/2 by 2x. 1/2 by 2x is simply going to give us x, and now we can multiply that x times our 2x, so we get 2x squared, and we're remaining with our 1 plus x squared to the power of negative 1/2. And of course, on our denominator, because we have our power of 1/2 being squared, this now simply remains as 1 plus x squared, according to our laws of powers. And that is a to the m to the power of n is the same thing as a to the power of m times n. So therefore 1/2 times 2 is going to give us 1. So again, our denominator is simply 1 plus x squared. So I want to continue to simplify my numerator as much as possible. I'm looking at my 2 terms in my numerator, and I realize that they both have 1 plus x squared in common. But what is different is the powers. And the first one, the power is 1/2, and the second one, the power is negative 1/2. So what I'm going to do now is use the laws of powers in order for me to simplify this numerator by factorizing. What is common to both these first terms would be 1 plus x squared to the power of negative 1/2. it's always easier to pull out the smaller power, and in this case the smaller power is negative 1/2, right? Because negative 1/2 is smaller than 1/2. So I'm going to pull out 1 plus x squared to the power of negative 1/2, and I also see that each of these two terms have the number 2 in common, so I'm also going to pull out 2. Alright, so essentially I'm pulling out 2 times 1 plus x squared to the power of negative 1/2 from both my terms in my numerator. So now my first term, which is this term here, after I've pulled out 2 times 1 plus x squared to the power of negative 1/2, my first term becomes 1 plus x squared to the power of 1. You have to make sure that if you multiply this by this, that you get back this number here. Right? So if you multiply 1 plus x squared to the power of negative 1/2 times 1 plus x squared to the power of 1, then since these are the same, what you'll essentially be doing, since you're multiplying, is adding the powers. And negative 1/2 plus 1 is going to give you back 1/2. So therefore that's our first term. My second term, which means I would have pulled out this and the 2, what is going to be remaining is simply x squared. So now in my numerator I have 2 times 1 plus x squared to the power of 1/2. I've pulled that out, and now I have 1 plus x squared to the power of 1 minus x squared. So now I am simplifying what's in these brackets here. Anything to the power of 1 is itself, so this is simply 1 plus x squared minus x squared, and x squared minus x squared is going to give me 0, and then 1 plus 0 is going to give me 1, and 1 times anything is itself. So my numerator now becomes 2 times 1 plus x squared to the power of negative 1 divided by 1 plus x squared. So again, remember what we're trying to show. We're trying to show that x times dy dx is equal to y over 1 plus x squared. So far, we definitely have our denominator already, and we have that dy dx term on the left hand side. So what we're trying to get now is to have our numerator look like y and somewhere have an x in the mix. So now I'm going to introduce the x in the left hand side by multiplying both sides by x. So I get x times dy dx is equal to 2 times, and I put in that x there to give you 2 times x times 1 plus x squared to the power of negative 1/2 divided by 1 plus x squared. Now I am going to rewrite this using a square root instead. So 1 plus x squared to the power of negative 1/2 means that I'm going to have a fraction now because it's negative 1/2, and 1/2 means that I'm going to have a square root. So this is going to look like 2x over, as in my numerator, is going to look like 2x over 1 plus x squared and square root. Square root means to the power of 1/2. Negative 1/2 means that we carry it to the denominator. So this is what my numerator is now going to look like, and that's going to be divided by 1 plus x squared. Great. So now we remember from our question that y is equal to 2x divided by the square root of 1 plus x squared. Right? So y is equal to 2x divided by 1 plus x, the square root of 1 plus x squared. Therefore, this means that our numerator is now y. So now I have x times dy dx is equal to y divided by 1 plus x squared, which is what we've been trying to prove. So we've shown that that is the case. Part 2 of the question says we have to show that d2y dx squared plus 3y divided by 1 plus x squared all squared is equal to 0. So again, we're going to show this, but we're going to use two pieces of information. We're going to use the fact that y is equal to 2x divided by the square root of 1 plus x squared. And then we're also going to use this information from the previous part, that x times dy dx is equal to y divided by 1 plus x squared. So recall from the previous part that x times dy dx is equal to y divided by 1 plus x squared. Now this also means that dy dx is equal to y divided by x times 1 plus x squared. Literally all I did was divide both sides by x. So I have one equation that has x times dy dx is equal to something, and then I have made dy dx the subject of the equation. So what we're going to do now is we're going to differentiate with respect to x. Since on the right-hand side we have a fraction, we're going to utilize the quotient rule when finding the derivative, and it's the same thing that we would have expressed in the previous part, that if it's of the form u divided by v, when we find the derivative, it is v du dx minus u dv dx, all divided by v squared. So, on my left-hand side, dy dx, when I differentiate with respect to x, becomes d2y dx squared. And on my right-hand side, I'm utilizing the quotient rule. So, v, which is v, du dx, which is differentiating y with respect to x, becomes dy dx, minus u, which is y, times dv dx. dv dx is the differential of our denominator. What we can do is we can expand our denominator, as in multiply x by 1 and multiply x by x squared, and we get x plus x cubed. So essentially we're finding the derivative of x, which is 1, plus the derivative of x cubed, which becomes 3x squared. And then on our denominator, it's going to be v all squared. So that's x squared and 1 plus x squared all squared. So this is my denominator here. So I'm now going to just write at the bottom here what it is we're trying to prove. So we're going to have that in our mind, what we're trying to work towards, which is we're going to show that d2y dx squared plus 3y over 1 plus x squared all squared is equal to 0. Right, so we would have just done our first step of differentiating with respect to x, and we're trying to get down to this. So now I already have my d2y dx squared, and what I want to do on my right hand side is simplify my numerator. So what I'm going to do is substitute dy dx, and we will recall that dy dx is the same thing as y divided by x times 1 plus x squared. So I'm going to substitute that into my equation. So now I have x times 1 plus x squared in my numerator, which can cancel with this x times 1 plus x squared in my denominator. That came from substituting dy dx for this. And now I'm left with y as my first term, and my second term is going to be minus y times 1 plus 3x squared, and then all divided by x squared times 1 plus x squared, all to be squared. Right, so now I want to simplify my numerator even further. So I'm going to expand my second term to get y times 1 will give me y, and y times 3x squared will give me 3x squared. So I end up with y minus y times 1 which is minus y, minus y times 3x squared, which will give me minus 3x squared. And then now y minus y will give me 0. So I'm left with negative 3x squared times y on my numerator. And of course my denominator remains as is. And now I look at my numerator and my denominator, which both have x squared in common. So I can cancel x squared in my numerator with x squared in my denominator to be left with negative 3y divided by 1 plus x squared to be squared. And this looks exactly similar to what we're trying to prove. So now what we're going to do is take our term that's on the right hand side of the equation and carry it over to the left hand side. So negative 3y over 1 plus x squared all squared becomes plus 3y divided by 1 plus x squared all to be squared. So this is my final result. d2y dx squared plus 3y over 1 plus x squared squared is equal to 0, which is what we're trying to prove. So we have accomplished that. Question number 6. The diagram below, not drawn to scale, shows the region bounded by 3 lines. Y is equal to 3x minus 7, y plus x is equal to 9, and 3y is equal to x plus 3. And the first part of the question says that we want to show that the coordinates of A, B, and C are 4, 5, 3, 2, and 6, 3 respectively. Now the first thing that we're probably going to want to do is really identify which lines are which. The first line that's easiest to identify would be this line here, which has a negative slope. Remember that our lines are always in the form y is equal to mx plus c, where m is our gradient. And if we were to put this line here, y plus x is equal to 9, into that form, we will get y is equal to negative x minus negative x plus 9, which means that this line here corresponds to y plus x is equal to 9. This line here is positive gradient, and it's going to have a high positive gradient. We're left with this line here and this line here. In the form y is equal to mx plus b, that means that the gradient of this line here is going to be 1/3, whereas the gradient of this line here is 3. Since 3 is greater, it means that it will have a steeper slope. So that means that this line here is going to be 3x minus 7. And this line lower down here is going to be 3y is equal to x plus 3. So if we're looking to find our point A, that means that that occurs when our line y is equal to 3x plus 7 intersects our line y plus x is equal to 9. So we're looking at the intersection of y plus x is equal to 9 and y is equal to 3x plus 7. What we're going to do is substitute our equation 2 into equation 1, and we end up with 3x minus 7 plus x is equal to 9. We put all the x's on one side and all the numbers on one side to end up with 4x is equal to 9 plus 7. So 4x is equal to 16. And then we divide both sides by 4 to end up with x is equal to 16 divided by 4. So x is equal to 4. This means that when x is equal to 4, we can now substitute this value back into this equation to find for y. So therefore, y is going to be 3 times 4 minus 7, which is equal to 5. So our first point of A is 4, 5, which is what we wanted to show. At this point in time, we're going to end this video. We're going to make a part 2 that gives the rest of the solution to number 6. So please stay tuned for part 2. Once again, today's lesson was brought to you by Limitless Learning TT. For more information on our services, as well as additional videos, please visit our website at limitlesslearningtt.com. You can also stay tuned for part 2 of the June 2015 CAPE Pure Math Unit 1, Paper 2, solution to number 6.